Hello everyone, welcome and thank you for joining this breakfast webinar about life cycle assessment in business decision. Today we'll talk about how to measure and communicate the environmental impact of a product in a way that actually helps business decisions, not just as a reporting. So my name is Okba Guedri. I'm a PhD researcher in green chemistry technology and sustainable food systems at Lund University here in Finland. I work with life cycle assessment or LCA in order to understand where environmental impacts really come from along the whole supply chain or value chain. So the goal of this session is more practical. So after today, you should see how life cycle assessment can actually guide product design and strategy in any type of organization. So, so before diving in, a few words about myself. I work as a PhD researcher and junior researcher for BioTechDemoDesign project. I'm doing my PhD in Lund University in Finland in the field of green chemical technology. My focus is on sustainable food systems, but the idea we're going to discuss today applies actually to any sector, from materials to consumer products to food science for designers. So basically any sector. Also, I have some experience working with companies and value chains. So I'm kind of trying to keep LCA linked to the real businesses and the real business challenges that we are facing, not only as a theory. Yeah. So if you have any questions, you can reach out to me by email. So let's start with why LCA matters for businesses today. So we are seeing a growing pressure from three directions at the same time, from regulations, from customers, and from also the investors. The regulation in the European Union and in other regions, they are asking for more transparent, standardized environmental information, not just green claims which are not supported or backed by any evidences. Also customers. So when I say customers, it's both companies and consumers. They are also asking for proof that products are like genuinely more sustainable, not just nice green picture on the packaging. Also, the investors are increasingly looking at the climate and other environmental risks before they decide where to put their money. So life cycle assessment actually help companies respond to all of this, but more importantly, it also helps them make better decisions inside their company. So first, on the product design side, with life cycle assessment, you can compare materials and processes early in the design phase. So if you do this early, you can actually avoid locking in a design that is very high impact. For example, choosing the wrong packaging material or choosing an energy intensive process and then building everything based on that. So since like once you have built the production line and signed the contract, it becomes very expensive and very hard to change. So doing LCA early can save both like emissions and but not only like emissions for the environment, but also money for the company. And second, in the supply chain, life cycle assessment helps to identify where the biggest impacts sit, what we call the hotspot in the value chain, and which suppliers are responsible for these hotspots. So like maybe the main hotspot is in specific ingredient that we can change, or maybe it's in particular component, or maybe it's in the long distance transport, so we can figure it out, like find another way of transport, bring in the raw material from local places. Yeah, so if we know the hotspot, we can interact in that hotspot. So when we know this, we can start talking with suppliers about lower impact alternatives, new sourcing regions, or different logistic options. Then third, we have compliance and reporting. There are many new frameworks that rely directly or indirectly on LCA-based metrics. For example, we have the CSRD, which is the Copyright Sustainable Reporting Directive. We have the Environmental Product Declaration. We have the EU Product Environmental Footprint. And we have various green public criteria, which are all built on life cycle thinking. So if you already have LCA work going on, it becomes much easier to fit that work into these reporting and labeling systems. And fourth, we have brand and trusting. So consumers and businesses are becoming like more skeptical. They have seen a lot of green claims, and they were these green claims, they were not actually backed up by any data. So when you can show that your claims are really based on a systematic ISO-based LCA, it reduces the risk of greenwashing and it builds credibility with stakeholders. So the key message that I want to say in this, like for this slide, is that LCA is not just a nice report at the end, or it's not just a claim that you can put on packaging. For me, it's a decision support tool that can guide a product design, supply chain management, compliance work, and also brand positioning. And it can help companies to avoid losing money, and also it helps the environment a lot. And if we use it in this way, it can become a very practical tool for businesses, not just for academic researchers. So let's start with where is life cycle assessment. So life cycle assessment, it is a science-based method that measures the environmental impact of a product or service across its whole life cycle, not just one part of it. It is standardized under ISO 14040 and 14044, which means there are internationally agreed rules on how to do it in a consistent way. So it's regularized by the ISO. So when we say a whole life cycle, we usually think of four big stages. The first stage is raw material extraction. This is where we take resources from nature, for example, mining metals or pumping oil or growing crops or cutting down trees. Second is the production and the processing. This is where factories turn those raw materials into final products. Here we use a lot of energy, we use water, chemicals, and we are creating a lot of emissions and waste. And third, we have in the distribution and use. So the product is transported, stored, and then used by the consumer. Maybe it's going to be used for a few days, maybe it's going to be used for many years. So it also needs energy and it's also create impacts. And finally, we have the end of life and recycling. So when the product is no longer used, it might be like reused, or it might be recycled, it might be like just burned, it might be landfilled, and each option, it has its own environmental profile. So in an LCA, we first map all the important flows in each of those strategies. We see how much energy, how much material, how much transport, what emissions and waste are associated with them. Then we translate these flows into impact indicators. So, such as, for example, climate change, water use, land use, and different type of toxicity, air toxicity, freshwater ecotoxicity. So we move from a long list of inputs and outputs to a set of like standardized indicators that we can compare between options. We can use these indicators to compare different options and we can choose the best one. So the real power of life cycle thinking is that it reveals the hidden hotspots that you would not see if you only look at one stage. So are like basically seeing it from a systemic point of view, not just a part of the system. So for example, a product might look very green in the factory. They might even promote it as green, but because, for example, they use renewable electricity or yeah, they're using like raw material from like any kind of waste or but like most of the impact might come actually from the raw material like production. If it's not from the raw material, if we are recycling, it might come from the processing, it might come from the use phase for many years. So without the whole life cycle view, we can we can easily optimize the wrong part. Since we don't know the hotspot, we can just like go and optimize the wrong part of the system and miss the biggest opportunities to really reduce the impact. So LCA follows a structure process with four main phases, but here I will explain them in a business language. So first we have the goal and scope, where we define the decision and the audience. For example, we want to compare two packaging options, or we need an LCA to support an EDP, which is Environmental Product Declaration. Second, we have the inventory, also we call it LCE, which is Life Cycle Inventory. Here, this part is very important because here we gather the data on energy consumption, on materials, on chemical used in the process, transportation, emissions, and waste across the full life cycle. Third, we have the impact assessment, where we convert those flows into indicators, like, for example, climate change, how much this product or this process is contributing to the climate change, how much of water use, resource depletion, how much is contributing to the toxicity, especially with the chemicals, the water ecotoxicity, the air. And fourth, we have the interpretation, where we identify hotspots where the major impact is occurring. We can compare scenarios, we can turn results into like a clear and applicable recommendation for the companies. So the ISO structure, like the ISO structure for LCA is kind of standardized and always stay the same. But what we can do is to always connect it directly to the business and to the business decision. So on this slide, you can see a system boundary flowchart. So when I say gate to gate, cradle to grave, So you can now understand it. So the purpose of this kind of diagram is to make it very clear what to include in the study and what to leave out. Because in LCA, one study is like they might consider only gate to gate, entry to factory, exit from factory. They might consider cradle to gate from raw material to exit from the company, from the industry, or they might consider the whole life cycle, which is from cradle to gate. So we usually start on the left with raw material extraction. For example, mining metals, producing chemicals, growing crops, or cutting timbers. So all of that, it belongs to the upstream part of the life cycle, and it already creates energy use, it creates emissions, it creates land and water impact, since here we are using like a lot of fertilizers, a lot of chemicals. So then we move to production and processing. This is where the factory turns those raw materials into components or into final products. In this stage, we include things like, for example, process energy. We must consider where this energy is coming from. If it's coming from renewable resources, yeah, it makes a difference. Process emissions and also waste treatment, how they are treating waste. Next, we have the distribution and use. So the product is transported, stored, and used by the customer. There are many uh, transport distances. There is fuel there is electricity during use, during maintenance, and also any consumable in the process. We need to consider it like in this phase. And then finally, at the right side of the flow chart, we have the end life or recycling. This can mean reuse, recycle, burning, energy recovery for landfill. Uh, each has its own like environmental consequences. So when we draw the system boundary, we draw a box. For example, my box is gate to gate. My box is cradle to gate. So when we draw the box around the process that included inside the study, that means that anything outside the box is not part of my particular LCA. Like either because it's like truly negligible, it has negligible impact, or because it's like a cut-off decision. We want just to focus on this process. So getting this system boundary right and documented, it's very essential for two reasons. First is to avoid the misunderstanding later. Everyone can see which stages and processes we are including. And second, it allows fair comparison. So if we have two products and we want to compare them, we cannot compare study gate to gate to another study cradle to gate and say gate to gate it has lower impacts. That's not true because they don't have the same system boundaries. So LCA on its own, it's just numbers. The output is just numbers, just tables. But its real value appears when we connect it to the real decisions and the real challenges in the companies. So in eco design and innovation, life cycle assessment helps to compare design concepts early so you avoid locking in high impact solutions. At portfolio and strategy level, LCA indicators, they help identify the high impact product line and prioritize these high impact lines for redesign. In sustainable procurement, companies can use life cycle assessment based criteria in supplier selection and also in public tenders. And for targets and KPIs, product level footprint support setting and tracking emission reduction goals over time. For example, I'm having a goal to reduce the emission 20% of this product, so I can track it over time. So life cycle assessment, it does not really replace like the decision, but it's a decision-making tool. It can help you make decision to save time, to save money, and to save the environment. So not every business decision needs like a full LCA, needs like a perfect, fully, very detailed LCA. So the key principle is that you can match the depth of the analysis to the importance of your decision, the decision you're gonna make, and start where you are. So we have different types of LCA. We have screening LCA, which is faster, typically takes days to few weeks, and often uses like generic or secondary data to identify hotspot. It is useful for early design, for quick comparison, if we want to quickly compare two options, and also for internal decisions. Then we have the other type of LCA, which is a detailed, what we call ISO compliant life cycle assessment. It takes longer, takes sometimes weeks to months to collect all the data and to build the inventory. And it combines primary data from the company and also secondary data. So, but we try to include as much data from the company as we can. So at this level, it's needed for EDPs, PEF studies, and also for public claims, and it often requires third-party critical review. So when we talk to decision makers, we need to focus on impact indicators that are like both meaningful and understandable for them. For example, climate change. Climate change is usually like the first one. Everyone can understand usually like this product is contributing to the climate change. Like the carbon footprint. Everyone is talking about carbon footprint, like which is often expressed by kilogram of CO2 equivalent per functional unit, which is like now it's the most requested in sustainability key performance indicator. But we have also other indicators like energy use, which is also very important. For example, cumulative energy demand and the share of renewable versus fossil energy, it really makes the difference. The energy is coming from renewable sources, if it's coming from fossil energy, if it's a mix, we need to know how much is renewable, how much is coming from fossil energy. Then we have water use, especially blue water consumption in cubic meters, which is critical for sectors like agri-food and textiles where we use a lot of water. We have here, if the hotspot is coming from water use, we can consider like recycling, we can consider different options. We can, for example, there is a company, they are working on potato chips and they are building one polymer to reduce the water use. This polymer absorbs water and keeps it for a long time, so they don't have to use a lot of water. Then we have land use and eutrophication, such as land occupation over time and nutrient runoff. So the important message here is to start with climate, but do not stop there. Check that improvement in one category do not create serious trade-off in others. That's like the biggest mistake people they make when they do LCA is that they focus, for example, on reducing CO2. Let's just reduce CO2, but in the other hand, they are increasing freshwater ecotoxicity, they are increasing other parameter, which is also dangerous. So you must always find the compromise. You must find the balance. So one of the most powerful outcomes of LCA is hotspot analysis. Hotspot in life cycle stages or processes are responsible for the largest share of impact. So hotspot, it means that a hotspot is like, for example, this stage or this ingredient is contributing the most to the bad impact. So when we identify the hotspot, we know where we should make the change. For example, for energy using product, the use phase often is dominated because consumers used like the product for many years. Also for food and other bio-based material, raw material production and processing are often the key drivers of impact. So with this knowledge, companies can focus, design, and resource like product change where they make the biggest difference, like in the hotspot. Without LCA, it's very easy to optimize the wrong part. It's very easy to invest in the wrong place. And you end up by not changing at all the overall footprint. You may reduce the CO2, but you are not changing the overall image. So when we communicate LCA results, we should always start with the business question, not with the methods and the databases. So first we have the why. Clearly, we should state the business challenge that we want to face. For example, how we want to cut the product X carbon footprint by 30%. Second is the how. We're going to explain the approach in one simple sentence. Third, we have what. We're going to present the key result and the main hotspot in one or two numbers or a single clear chart. And finally, so what? Like we explain the concrete implications, what design sourcing or strategy changes follow these results. So these structures keep the audience engaged and focused on what they really can do with these insights. So most non-experts struggle with understanding the long table of LCA outputs because if you go to OpenLCA, you do LCA, the result is like a huge Excel file that you can export with many numbers that if you are not expert in the field, it's very hard to understand. But with a good visual structure like this one you see on the screen, we can tell the story in seconds. Like, for example, a clear bar chart or pie chart that shows contributions by life cycle stage. This stage is contributing 20%, this stage is 50%, or by component. It's easier to read. It's easier to read than a full life cycle table. Also, we limit each slide to 2 or 3 scenarios and only the most relevant indicators. We're going to highlight like only the most relevant indicators that contribute the most. Also, when possible, we translate key numbers into comparison. For example, this option is equal of driving X kilometers in car. So the detailed table sensitivity analysis, we do also sensitivity analysis or what we call Monte Carlo simulation and uncertainty discussion. So we can keep all this in the background report or in the appendix. So good communication with life cycle assessment requires both transparency and focus. So we always disclose the key elements like functional unit, system boundary. It is our functional unit, for example. What is our system boundary? It's cattle to gate, it's gate to gate, it's Yeah, the main data source from where we are gathering the source and the quality. And the quality, we can assess it with sensitivity analysis. And the main assumptions, if we are missing some data and we are using some generative data, we must also mention that for credibility and for honesty. Also, we state which impact category we are assessing and whether the results are reviewed externally or not. At the same time, we cannot overload the audience, so we show only what really matters for the decision, and we can move the rest to the appendix or to the technical report. Also, details such as full category results, allocation methods, database version, raw inventory tables are very important, but usually not for the 5 minutes like presentation. Let's move to the second slide. Yes. So single life cycle assessment study, so it can support many communication format. So an LCA under standardized ISO 14040 and 14044, it can usually do like internal analysis that document all the impact category, all the data, all the method, and it becomes like the basis of external use. We can use it in many reports. So from that, we can develop an environmental product declaration or EDP, uh, yeah, which is type 2 eco-label under ISO 14025 based on specific product category rule. EDPs are widely used in business-to-business tenders and procurement, especially in construction, in packaging, in food sector. Also, the EU Product Environmental Footprint, or PEF, which is a harmonized method with PEF category rules by the European Union, which is increasingly like been very important for the EU Green Claim Directive and Digital Product Passport. So the same underline LCA power EDP's PEF-based communication, so we can use it in all these kind of reports. So this slide highlights some common mistakes that can damage the credibility when we are using LCA. The first is carbon tunnel version, focusing on only the CO2 and forgetting the other impacts like water, like land use, like ecotoxicity. So to avoid this, we must always screen at least the core set of impact category, even if we communicate only the main ones. Doesn't mean that I'm communicating only climate change or CO2 that I don't have to to analyze the other climate results. The second mistake is comparing uncomparable studies. For example, mixing results that they don't have the same functional unit or they don't have the same system boundaries, and we try to compare them. It's not possible here because it's not the same context. Then the solution is to align the scope before comparing. For example, we compare gate to gate with gate to gate. And we clearly flag any differences that remains. Other mistake is over-interpreting small differences that are within the uncertainty range of the data. So there is a better focus on, we better focus on the large differences, and we can use sensitivity analysis. And finally, greenwashing. She's presenting selective results without disclosing the assumptions or the limitations. So now let's look at 5 concrete steps any company can use to start with LCA. First, define the decision and the audience. Frame the goal and scope around the question you need to answer, not only around the data you already have. Second, run and screen LCA. Use secondary data to quickly identify hotspots if you are doing screening LCA. And you can decide to keep study if it's needed. And third, involve cross-functional teams like research, development, sustainability teams, marketing. They can all act on the results. And fourth, we should choose the right framework. For example, EDPs for construction and B2B, PEF for EU consumer market and internal product footprint tools and strategies. And fifth, build credibility gradually. So perfection is not required at the start. We can start with basic LCA and we can develop it over time when we have more data. So here is a case study. I can share with you the paper. It's already published and I have extracted the data from the paper and I have simulated and presented like in a simple way in bars. So this case study is comparing conventional bovine leather with different plant-based leather, which is a very relevant topic. So it shows that the average bovine leather can have around 22.5 kilograms of CO2 equivalent per square meters, which is based on a large study of chrome-tanned product. At the other hand, one bio-based leather in the study, it shows about 80% lower greenhouse gases and more than 95% lower eutrophication, land use and water impact compared to the bovine leather. Also, the study was made on mycelium-based leather, which is a very recent study. It had the lowest impact across all the categories compared with the bovine and the typical leather. Also, cactus and pineapple leather is recently reviewed, and it has 0.8 to 8.8 kilograms of CO2 equivalent per square meter, depending on the product. So, however, there is many trade-off, many plant-based leather, they are like still limited by biodegradability. So the business implication is that switching to high-performing bio-based leather can cut material level greenhouse to roughly like by 70 to 80%, and it reduces a lot land and water and eutrophication compared to the conventional leather. So now I want to close with 3 key messages to remember. So first is that LCA reveals where impacts really occur across all the life cycle, often in places where you do not expect it to be from this place or from this spot or from this chemical or from this component. So without this few optimization effort are misdirect, you can start to optimize the wrong part of the process, a part which is not generating a lot of bad impact. Second, LCA, it's a decision to support tool for eco-design, for procurement, for portfolio strategy, and target settings, not just reporting for research or for requirements or for legislations or for greenwashing shield. And third, communication is very important as the study audience-oriented hotspot. Visuals, clear assumptions, and honest discussion of the trade-off on what builds credibility and drives the real impact. Yes, so thank you very much for your attention. I would be happy if Ella have any questions. I can answer your questions. For other people who are watching the recording, you can reach out to me by email anytime with questions. Yes, that's gonna be all.